learners, welcome back to our chemistry class. Today is going to be the continuation of our chemical combination. If you are just coming across our channel for today, kindly subscribe to my channel and click the notification bell. And also do yourself good by clicking the description box below to view the first class. Now today, we are going to be looking at covalent combination in our chemical combination. We've talked about the electrovalent combination, otherwise known as ionic combination, which talk about the complete transfer of electrons from metal to a non-metallic atom. Now, for covalent combination, a covalent combination involves the sharing of electrons between the atoms of elements. The elements might be the same elements or different elements. They are going to share the same amount of electron within themselves in order to form the covalent bonding in between them. Now, when we look at this covalent combination, majorly, all covalent combination lead to the formation of molecules. For example, formation of hydrogen gas or hydrogen molecule. Hydrogen molecule can be written as H2. This H2 can be broken up into hydrogen atom and another hydrogen atom. The first hydrogen atom has a K shell of 1 and the other one of 1. So when we draw the electronic structure of the first hydrogen, the K shell having 1 atom plus the second hydrogen, the K shell having 1 atom. When you look at this, they are having one atom, and in this case, they are not stable. And for hydrogen atom to be stable, it has to possess 2 electrons in the K shell to form a duplet structure. In this case, it forms. So sharing will come up here. The first hydrogen atom share with another hydrogen atom. They are K shell. So here we have electrons in the first hydrogen atom, and the second one also the another electron. Now when we look at this now, when you count the electron in the first hydrogen, we have 1, 2, and second hydrogen 1, 2. So this is now hydrogen molecule. So if I want to use a line to represent this as the bond in between them, I'm going to say H to H. So it's forming a single bond. 1 hydrogen, this is 1 electron here. So this bond now we have this one is donating 1 and this one is donating 1. So we're having 1, 1 and another 1. So we are having a bond in between them. So this is called a single bond. It's called a single bond. Now another one, let's look at formation of chlorine atom. Formation of chlorine molecule. Here we have Cl2. When it breaks down, it's going to form Cl plus Cl. We know very well that chlorine has an atomic number of 17. Then for the first one, having K shell 2, L 8, and M shell 7. For the second one, K shell 2, L shell 8, and M shell 7. Now when we draw the electronic structure, let me draw the outermost shell of this, which is, we know the K to be 2, L is 8, they are complete already. Let me draw for M shell. We have K and L. We have 7 electrons. So this is for the chlorine atom, plus the second, we have K shell, L shell, 2, 4, 6, 7. So when we look at this, in order for this first chlorine atom to complete the octet structure, it needs 1 electron, while this one also needs 1 electron, in which none of them are ready to donate the electron. In this case, they have to share the electrons. So leads to this formation. So we are going to have 7 electrons here, 2, 4, 6. So this is 7 electrons. And for the second one, 7 electrons, 4, 6. Now the remaining electron is this. Now from here now, you cannot see that from this one we have K L, and this is M shell, K, L, and this is M shell. Now, when you count the electrons in this one, we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 electrons here, which is the octet. Then this one as well, 1, 2, 3, 4, 5, 6, 7, 8. We have 8 electrons. In this case, we have chlorine molecule. Now, this chlorine molecule now, you can see that we are having is one electron being donated here and another electron being donated here. So here we have Cl and Cl. So which means the bond between the chlorine atoms, they are what? Single bond to form chlorine molecule. Example 3. Formation of oxygen gas. Oxygen is O2, which is oxygen plus oxygen atom each. The first oxygen atom has an atomic number of 8, as we know. Second one, atomic number of 8. So we have K shell to be 2, L shell to be 6, K shell to be 2, L shell to be 6. So K shell, L shell, 2, 4, 6. So this is oxygen atom. Then to another oxygen atom, K shell, 2, and L shell, 6, another oxygen atom. Now, for these two oxygen atoms combined together, you can see that the first oxygen atom has 6 electrons in the outermost shell, in which case, these 6 electrons want to complete octet rule, likewise this one. So, none of them is ready to donate and they cannot donate. In this case, they have to pair together, they have to pair in order to balance. Now, let me show the outermost shell, which is the L shell, for each of them. Now, the first one having 2 electrons, we have 2, 4. Let me pick 2, 4. Now, out of these 6, it will enter into this place. That is for this first shell. So, we are having K and L, K shell, and this is L shell. Now, for this one as well, we are having K and L. I'm going to pick 1, 2. That is, I have 2 and 4. Then, the remaining 2 that remains here, it should be inside this. So when I count the electron in each of the orbitals, I have 1, 2, 3, 4, 5, 6, 7, 8. So for this, we have 8 electrons. Octet rule has been attained. For this one, 1, 2, 3, 4, 5, 6, 7, 8. Octet rule has been attained. So this is our oxygen molecule. This oxygen molecule, that is O2. Meaning that oxygen combine using 2 electrons. We have the first pair of electron, second pair of electron, so we have it this way. So oxygen molecule is bounded together by double bonds. So this is one of these bond is made up of 2 electrons, 1, 2. Second one made up of 2 electrons, 1, 2. So oxygen molecule is made up of what? Double bonds. And that type of bond between them is called covalent bonding. Example 4, formation of nitrogen. Here, nitrogen is written as N2, that is 2 atoms of nitrogen. The first nitrogen has an atomic number of 7. That is, our K shell is 2, our L shell is 5. Likewise, second nitrogen, atomic number of 7, K shell is 2, L shell is 5. When we draw the electronic structure of the first one, K having 2 electrons and L having 5 electrons, we have 2, 4, 5. Likewise, second one, this is a nitrogen atom. Second one, we have K shell, 2, then L shell, 5, 4, 5. Now, in this case now, each of these atom want to attain an octet rule. That is to have 8 electrons in their outermost shell. This is having 5, this is having 5. For this to complete 8, it needs 3 electrons. This also needs 3 electrons. So in order to complete. Now let me show. I'm going to show the outermost shell for each of them. Okay. So the first one, we have our K shell, now L shell, outermost shell, taking 2 electrons here, 2 electrons. Then the remaining 3 electrons, let it be in this. Now for this one as well, second one, we have the K shell and L shell, taking 2 electrons here. So I'm going to have 3 electrons that remain in the outermost shell. So when you count the number of electrons in each, for the first one, I have 1, 2, 3, 4, 5, 6, 7, 8 for this one. For this circle as well, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8 for this circle. So this is nitrogen molecule. So if I want to now write this nitrogen, now in between the first nitrogen and second nitrogen, we are having 1, 2, 3, 4, 5, 6. You know, 2 electrons is denoted 1 bond, second 2 electron, another second bond, and third bond. Meaning that between one nitrogen atom and the next, we are going to have triple bonds. So nitrogen molecule is having triple bonds. Example 5, formation of water. And water is NH2O, having 2 hydrogen, atomic number of 1, second hydrogen, atomic number of 1, joining with oxygen. Oxygen, atomic number of 8. K shell of this equals to, K shell equals to, here K shell is 2, L shell is 6. So for the first hydrogen atom, having 1 electron in the outermost shell. Then for the second hydrogen atom, having 1 electron in the outermost shell. Then oxygen, K shell is 2 and L shell is 6, 2, 4, and 6. This is oxygen atom. Joining them together, we are going to have, I'm going to show the outermost shell for this oxygen, K shell and L shell. We have, let me say we have 2 electrons. Then one of the hydrogen is coming. We have 1 hydrogen, 1 electron, and out of 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, then 5, 6. So one of these hydrogen is coming here. Another hydrogen is coming here. So one of this this electron now is to be here. This electron is to be here. So in this case, they have formed water molecule. That is what? H2O. Now, this is oxygen. Oxygen, we have 2 electrons. We have 2 electrons. Then this is hydrogen. And then hydrogen. You can see this is single bond. This is single bond. So this type of bonding here is called covalent combination. So this is how to understand the drawing or the explanation of covalent combination. If you enjoyed this class so much, kindly subscribe to my channel and click the notification bell for my subsequent content. Thank you very much.